Hello and welcome back to Mastering C++ 20 Features. In this lecture, we will look at how to resume a suspended coroutine. In the last lecture, we looked at the coroutine foo, which had two stdc out statement and a co-await statement that suspended the coroutine. And then we had the associated return object of the coroutine, which had an underlying promise type object. The promise type object is required to create a valid return object, and the promise type object also needed to have a specific structure. So, namely, the promise type required an initial suspend method, a non-throwing final suspend method, a getReturnObject method, and an unhandled exception method. And then, if you recall, the getReturnObject is the method that gets executed the first time the coroutine is called, and this method constructs the return object from the coroutine. Therefore, we are able to do something like this because the getReturnObject is executed. So we are able to capture the return type here. Return object. And then next, the method initial suspended is executed by the runtime system to check if the coroutine should be suspended on the first call. In our case, the core initial suspend method returned std suspend never, which indicated to the runtime system that it should not be suspended. And therefore, the first print statement is executed. If we compile and run this, we see the hello statement from the coroutine here. I'll clear the console and rerun it once more. So here we see the first hello statement on the coroutine. If we use std suspend never instead of suspend always in the co-await, then the second std cout statement also gets executed and appears on the console. Here we go. We see the hello again from foo because we use std suspend never, which indicated to the runtime system that the coroutine should not be suspended. Let me revert it back. Now the question is, how should we be able to resume the coroutine even if std suspend always is present? If we look at the CPP reference page, there's a std coroutine handle associated with the coroutine, which is provided by the standard, and it is this object that we should be able to use and resume the coroutine. So this is a class template and have three specialization. One is a primary specialization. The primary specialization is associated with the promise type, which means this promise type. This is the primary template specialization for coroutine handle. And then the second template specialization, which is of type void. The third specialization will ignore for the time being. The void simply means no template parameter. And we have the method resume or the operator overloaded bracket operator. This method resumes the execution of the coroutine. Another method of interest is a static method from promise, which creates a coroutine handle. We'll come to this shortly. So what we should be able to do is through the return object access the coroutine handle and resume the coroutine from its suspended state. Something like this. Or we should also be able to do something like this and call the overloaded bracket operator. I'll put it as a comment. And since we don't have a coroutine handle attribute in the return object, we go ahead and provide this attribute. I'll first use the void template parameter specialization. This could also be written like this, but I'll remove the void from here. To be able to initialize the coroutine handle, we need a parametric constructor. So we provide a parametric constructor also. and I'll leave the body of the constructor empty. All right, so far so good. And recalling that, the return object is created by the method getReturnObject, and therefore instead of calling the default constructor here, we call the parametric constructor. We copy this. And now again, let's come back to the documentation and look carefully at the fromPromise method. FromPromise method is a static method that creates the coroutine handle from the promise object of a coroutine. If you open this, it says, the documentation says that this method creates the coroutine handle from the promise object of a coroutine. The created coroutine handle refers to the coroutine, and this function is only provided for the primary template specialization, that is specializations of coroutine handle of type void, and the other coroutine specialization does not have this function. So we need to use a primary template for creating this, for using the fromPromise method on std coroutine handle, and use the primary template. And on this object we call the fromPromise, and in the fromPromise we need to pass the promise type, current promise type, as a value. Therefore we dereference the this pointer and pass it as a parameter. Note one thing here, the promise type, the coroutine handle that we pass on to the constructor has a template parameter promise type, but here the template parameter in the argument of the constructor is empty. The CPP reference page for coroutine handle says specifically that the void type is convertible from other specializations. So therefore, the void type coroutine handle template can be converted from the primary template. And finally, let's try to compile this first and see if everything works. Yes, everything works, and we also get the second hello from the coroutine because we attempted to call the resume statement. If we comment this out and again compile it, we'll see only the first hello statement is executed. If we copy this awaits this std suspend always and put a third print statement and call the resume method again on coroutine, we see only the second statement getting printed, and then the coroutine is suspended here, and we try to call the overloaded bracket operator, and here the third statement also gets printed. Finally, we can also check if the coroutine has finished execution by calling the done method on the handle, like this. This converts the boolean to true or false strings on the console. So what we are interested in is this, it opt. And we get a true because the coroutine has actually finished execution at this point. And if I comment this out, we get a false because coroutine executed only 2 print statements and got suspended at before the third print statement. So that's it for now. I hope you enjoyed learning how to resume the coroutines, and in the next lecture we'll see a little more details and tricks on how to access the coroutine handle. That's all for now. Thank you. Hello there. If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website, mastering-modern-cpp-features.thinkific.com. Thank you.